We're going to do it one more time. Tonight, we're going to be solving the final level of the Excel challenge WhoDunnit by Harry Watson one more time. If you've not seen the previous video on this, don't worry, I'm going to bring you up to speed in just a moment. But if you have, you'll know we've already seen two great approaches on how to solve this level. And today, I'm going to try and solve it with a bit of a twist. And no, it's not just an XLookup version. Honestly, I don't know where you would even begin. If you don't know what I'm talking about, I will really quickly run you through a reminder of what's going on. So, in this case, which was the Road to Las Vegas battle number 2 for the Microsoft Excel World Championship this year, just last week, we had lots of coded messages to decode. It was a little bit like Clue or Cluedo, depending on where you are in the world. Different people committing different crimes, a little bit of correspondence, some ciphers going on, and the final level was a doozy where you had to translate these messages here. You knew a couple of things. You knew there were 2 different ciphers going on. One was an ordinary shift and one was the long shift. You knew which crime they were talking about, well, that's what you're looking for within the correspondence. And then from that, you need to work out who sent it. You can see I've already done some setup. I've copied this down to there. I've also got a couple of other bits that I've done that you'll see as we go through. Essentially, it works like this. If we wanted to get all the letters out of this and take the Unicode of those letters, the way this ordinary shift would work is we would just add that number onto those, so 8617. And then we would use unichar to turn those back into symbols to make our message. Now, this ordinary shift comes from who sent the message and who they sent it to. There's another bit of shifting going on, though, in this case, and that's the long shift, which I've demonstrated here with the sentence, if I had a hi-fi, which, definitely I'm on the songs tonight, which is a palindrome, as you can see, and we've split that out into its individual letters like we did before. This long shift depends on the day of the week, which we'll cover in a moment, and it indexes each character at 0 onward. So the first character is 0, the second character is 1, and so on. You then take that position and you multiply that by the long shift, which is based on that day of the week. Now, that day of the week is the first word in this message. So on the other approaches to this, I looked at the first word, used that to work out what the long shift was, use that to work out the ordinary shift, and use that to work out who sent it. Today, we're not going to try, well, today we are going to try to not use that first word at all. We will need the long shifts because that's part of it. But this is based on a conversation I had with Dim. He was talking about converting each of these days of the week into a signature based on the difference in letters between them, difference in Unicodes between each of the letters, and using that. And I thought, if we can do it that way, why can't we do it straight from here? So there's a few things that we'll need. The first of which is going to be getting this correspondence onto the case page. Let's start a timer and see how long this takes. Now, I've done most of this before. I've just done some tests on it. It seems to work. There's a couple of bits I've not tested, and I've not done it through end to end. I sound like I'm on Bake Off when I say that. I've not tested it through end to end, but hopefully this will still work. I'm going to start by, let's make this a let, and let's grab this one here. The reason for that is just so I can copy it down without getting loads of NAs in the middle. I'm going to lock it to the column. In fact, I want that there. And then for the letters, we're going to open up that word as we did before, as I was walking you through what we're doing. And then we're going to take the Unicode of those letters. There we go. So what we want is we want to know how to get from 65 to 67, so adding 2. To do this, we're going to free stack those codes. So we've got 2 copies. We're going to get rid of the first one on the top and the last one using the index of -1 on the bottom. We're going to turn those bottom ones into negative numbers, and then we're going to bicol over this whole thing using sum. So A to C is +2, C to O is +12, O to S is +4. So this is going to be the diff between. Okay, a couple of things to note here. The first is, for this diff between, we also need to work out with our along shifts. So we want 7 starting from 0, 1 to 6. Why am I saying we need to worry about that? So the way that this works, if we just grab this a second and return our codes, we can see that we've gone from 65 to 67, which is +2, etc., etc., etc. If our along shift were 3, then we would also have a sequence of the number of columns that we have here, starting at 0 and stepping at 3. So the 0th position, the first position is 3, second one 6. And we would be adding that on to our codes. But when we do our steps between, so if we do this, take away this, and this, take away this, and this, take away this, that's our last one there. And we then take away our initial steps between, we'll see we're left with that straight along code. So we don't need to worry about the index within the thing, which is, that's the key to letting us do that with, without getting the day of the week. Essentially, it doesn't matter where it appears, each one is just going to be added on by that along code. So let's fold our along code into this logic. Our along code in this scenario is that 0. And we're just going to add our along code to that diff. So it's not going to change the first one, but from here we're going to see things go up. I'm going to get some spill errors. That's not a problem for now. The other thing that we need to worry about is the fact that in this particular challenge, we weren't converting numbers. So the simplest way to do that would be just to get rid of the number, but then within the message, we will have shifted along an extra position. So if we solve it at this stage, I don't think we'll need to do it within the message. I've not followed this through to end to end yet, end to end. So we will see. But I think we're going to need the individual letters. We're going to say is number, and that's going to be a regex test of letters with that. There we go. So that is because I can't spell the word letters. That's going to give us false for all of those, but for this one, it's going to give us true because the fourth one is a letter. So what I want is a number adjustment, which is going to be, we're going to get rid of the first of is number. And we are going to times that by the along code, which we can see is giving us an extra 3 or whatever there. We then also need to drop off of it, off the end, how many were a number. So the sum, the minus, so from the end, so minus sum of is number. So that should still give us 3 there, and that should give us 5 here. 1, 2, 3, 4, 5. Because we've got 1, 2, 3, 4, 5, 6 things. So 1, 2, 3, 4, 5, 6, 7 characters, so 6 gaps, but 5 gaps because we're getting rid of the 2. So now we want diff between plus number adjustment as our codes. One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Which one's giving us 6? It's because I've not actually filtered out here. So on the codes, we just want to filter that by not isNumber. Now, we could have done that the other way around and had that be anything trues and falses, but then we'd have to have flipped it later on. So we'll just do it like that. There we go. That's what I want. That is exactly what I want. And so now this is going to be our signature, is going to be the array to text of this. And we're going to return that signature. So this is our signature for each of those. We now need to do the same thing here, bearing in mind that we don't need to worry about the long shifts because we've already taken care of those long shifts. So we are going to text split these messages and we're going to map, I love map, I've been really getting into it recently, each of those words to use the same logic. Let's just go in and grab this a second. Cool. So we already have the word. So we're going to split it into letters. We're going to filter it based on not isNumber. We don't need to worry about the long code. We do need the difference between, and then the signature should just be that difference between. And now that's giving us a calc because we've got some words which are one character, I think. It doesn't matter if it's one character, it doesn't matter what I put in there because we're not going to need it. Cool. I'm not actually going to do this down the whole column. Instead, what I'm going to do is I'm going to use this logic in a moment. So we're going to say, I'm going to use that logic right now. So we're going to say by row of all of these messages. So for each message, we are going to perform this lambda function. And this lambda function is we're going to say the words are the text split of the message by the space. And then we're going to word sigs. So the signatures are going to be that map. And then at the minute, all I'm interested in is isNumber x match this code here, this signature here, in word 6. I think that is all I want for now. So I'm going to sum this with the unary operator to make it ones and zeros. So that's going to give us 0, 0, 1, 2, 3, 4, 5, 6. If this has worked, one of these will be a 1. It has not worked. Okie dokie. Let's do some testing to see why that's not worked. None of those look like they're saying true, do they? Okay. So for each message, we are splitting up the message. Map. What is that? Map words. Silly boy. There we go, there's a true. Is that the only true? This is where that sum comes in. Okay. So there's only one where it's true for that first one, which is great. Let's just make sure we've got exactly one true for each of these, and then we can go back to working out what we're doing. Looks like we do. Excellent. So we now know the long shift for each of these. What we can do one better. So that's the word 6. if we go back to just doing the single one, this is the one where we've got the match. So we know it's a long shift of 5. Instead of is number, first of all, instead of summing it up, let's get rid of that. Instead of is number, let's just get the X match. So that's going to give us 4 here and an error everywhere else. And for these ones, it's just going to be errors all the way down. It's no use, it's errors all the way down. Okay, awesome. Cool. So I'm going to call this the match word for a moment. And this is going to be the index of words by that. And then what color am I meant to be at? Purple. Cool. And that's going to be match word. And that's going to be an error for everything apart from our match word, which we now have. The other thing we need to know is where in the original sentence that occurs, because that is the position at which we're going to be applying our long shift, which we can already work out what the long shift is. Okay. Are you staying with me? This is complicated, but I think pretty cool because we're not using that day of the week word. So that's our match word. And then I'm going to return our match word, and separated by a colon, I'm going to return where is that match word within the message. There we go. We can see we've got, it starts at character number 22. Cool. We're going to take that number and we're going to multiply it by this, our long shift. This is fun. Cool. And then we're going to do, on the whole thing, we're going to call to get rid of all the errors. Is this going to work? Is this going to work? Please work. Okay, so that's going to give us errors on everything else. But that's fine, I think, as long as when we get rid of the errors going the other way, we have exactly one non-errors one for everybody. I think we do. Okay, so we want, first of all, we want the Unicode number of the left character of this. And we want to take away the Unicode character of the left character of the word we are looking for. And we want to take away, what do we want to add? I think we want to take away the number value of the text after of this with a colon. Now we need to go to our people tab. We're going to make a nice column of these lovely things here. And we're going to make a nice column of if sequence rows of this, then these. Is that what I wanted to do? Amelia, Benjamin, Clara, David. Amelia, Benjamin, Clara, David. Excellent. Oh, moment of truth. We're going to look up those codes. In those codes, returning the sender name. Oh, not quite. Okay, what did I do wrong? Got Mia for the example. Do I want to add on that thing there? No. So we've got the position. Okay. I think I know the problem. It's because of this whole off by one thing. We did not take into account the fact that it's the position minus 1. That gives us Rachel, so I think that now will give us what we want. There we go, full house. Ooh, okay, right, so just to recap, we took each of these words and we turned them into a signature based on the number of characters you were moving between each pair of letters, the gap between each of those Unicodes. Let's stop our timer. Nearly 17 minutes. So we did that. We took out the numbers because we didn't want to worry about the numbers. And then we adjusted that number because we'd taken out numbers. So we added in an extra long shift if we skipped over a number. We then applied similar logic, but way simpler to each of these messages in turn. And we used that to find the word that was the one that we wanted, because it had to be one of these 7 options, and find the position of that in the original sequence. Took 1 away from that to find the 0 index version of that, multiplied that by the long shift that was the version that we were looking at, and then used that to reverse engineer what that sender's code was. Ooh. All of that without using the day of the week as the first word. Whew. I don't know about you, but I am tired after that. That is ridiculous. It is a lot of fun. I like breaking the fact that we don't have the what do you call it? The day. We're not using that day at all. We are using a long shift, but those long shifts could have been anything in this case, right? We could have done this for 50 different long shifts, 100 different long shifts, and it wouldn't have mattered. We didn't need to know where this word was. We didn't need to know any of that sort of stuff. I think this is a really cool solution. I would love to know what you think. Do you think that this solution is too complicated? Does the complexity make it interesting to you? I'm having trouble following what I even did now, but it worked. The fact that we were able to prove that there was exactly 1 for each of them was great, because it meant we could just condense the next step of logic into this ridiculous function here. We used toCall and toRoll to deal with errors, and there we go. Excellent. I really enjoyed that. I hope you did too. If you want to check out a different video to do with this, then the algorithm thinks you'll enjoy, which side is it? That one next. There you are. Hello. And until next time, as always, keep excelling.